So this is day number 3. We've made it this far, but we haven't done any activities yet. So day number 3, activity number 1. And day number 3, activity number 2, we're going to put them back to back for the rest of this class. So you guys can really crank out and get everything done before you have to leave. So assignment number 1, or activity number 1, I should say, is working with Scheme again. So you're going to write a function in Scheme. Hopefully you still have Scheme loaded. And it's going to say a minimum min list that returns the smallest value in a simple list of integers. There's a million of these functions on the internet. Try to write it yourself. You'll get more learning out of it. But you can possibly go through much of the documentation. In fact, even the lecture note probably has it in there. But you're not limited to the built-in functions, the 6 built-in functions. You can use anything you want, any technique that you want to do it. So the second function is myRemove. It's going to take, and I had a couple of people ask me what this word here means. Make it seem like an item. So an item could be a string, an integer, a function, another list, a list within a list. It's a component or an item. So you're going to myRemove is going to remove an item from the list. So that removes all occurrences of this item from a simple list. So if it said remove A from A, B, and C, it removes A from A, B, and C. So don't think of that too much. I mean, don't get too complicated with that concept. The third one is going to be a selection sort. This one's going to be the harder one. Or not the harder one, the most challenging one. It's not really hard at all. It's going to return a simple list of integers in ascending order using a recursive selection sort algorithm. Hint, use your minimum function. So you can reuse your minimum function over here, and that will actually make the selection sort a little bit easier for you. If you need a background on data structures, you can't remember, or algorithms, you can't remember selection sort, there's one actually in one of the lectures that I gave you already on Scheme. But it's also on the help site of the Scheme, Dr. Scheme Racket website, which I forgot to point out before, so I'll point it out right now actually. On both websites for Prolog, there's documentation that you can download, and also for Scheme. So if I come in here and go back to Dr. Racket here. Actually, if I shut this, it might actually run a little bit faster. And go Dr. Rackets. The Racket language. Documentation. If I click on documentation, I see nice little tutorials. This stuff is better actually than just doing a Google search. You'll find more suited examples. Simple HTML rendering for a browser, simple network examples, simple tools, an overview of Racket with pictures. So you can see here how to download Racket. And here we have pictures, 5, art gallery. It actually gets a little bit more complicated towards the end here when it starts loading, defining for P, putting circles. Actually, it might learn a few things that, in fact, here you can create a chessboard if you want using graphic components. Excuse me. You'll also get the same thing with Prolog. So just going back into Strawberry Prolog, I believe it's right from the main menu. There's a couple of tutorials out there. There's no language to pick. Prolog is Prolog. Scheme comes in all different varieties of languages and choices. Prolog is just Prolog. So Prolog is actually easier because you can find more examples on the internet. But if you look over here, used to be a support. They used to put it out in a Word document. Let's go, maybe it's under information. It appears towards the market that they're trying to hit right now is primarily game programming for Prolog, which Prolog is used a lot for the gaming community. But let's go into download for a second here. It used to be kept separately, which is why I'm looking at it. There is a paid version of Prolog. Do not pay for it unless you want to buy it. But there's a professional version of it, a little bit better. More documentation inside of it. The free version of it doesn't have it, you can actually download the source and create your own dialect of Prolog. People like to do that because it's easy to hybrid it into another system and have a C program call the program functionality for Prolog and then integrate the results in. So you can kind of create a more user-friendly programming environment. But I believe that there, if you search through it, there should be, I thought it was through the support, but there should be some information out there on Prolog itself. So that is the first assignment that we're supposed to do today. The other assignment that we're supposed to do today is in Prolog. So the last one was in Scheme. Excuse me, assignment number 1 is in Scheme. Assignment number 2 is in Prolog. And the Prolog example here, this is going to be Strawberry Prolog. This link is slightly different. If you click on the link, it's going to take you to another website. It doesn't matter what version of Prolog you download and use. I think it's going to forward to the Strawberry site, but let's just see what happens on the SWI Prolog. Nope, SWI is a different version of Prolog. You might experiment, you might find one more user-friendly than another. The languages are identical, so you don't have to worry about that. They're both compatible with each other. But Strawberry is probably going to be the easier choice. Who knows? And then you're going to answer some questions. So here is a brief introduction to Prolog that you're going to get in here. It's going to set the stage for you. And then you're going to have some facts here and some examples of some facts. And then down on the bottom, you're going to see some queries that are being run. And then your assignment. So given the relationships, and here's the relationships, define Prolog relations for the following. Sibling, sister. What you're doing is you're defining, and if you look at that lecture I just gave you, it's giving this to you in another family tree example. So we have father XY, mother XY. This is the same as the example I gave you in the lecture. So do a Prolog define Prolog relations. Give me the Prolog syntax for the relation of a sibling, or for brother sister, or for sister, or for grandson, or for descendant. So some of them are kind of interesting. That's all you have to do. Provide some facts for the father, mother, predicates, and then test the entire thing using Prolog if you want. If you do this, and you really do it, save it. Because your assignment is going to work off the same premise. So this is going to help you with one of the assignments that you're going to need to do. And then, some of you looking at me, well, if you haven't been paying attention, I gave this to you in one of the lecture I just gave you. So you can take it from there, or you can probably find something similar to it online. Don't have to give me a full Prolog program. Just give me the relations that you're going to be. So you're going to have A, B, C, and D. You're going to have 4 different answers to this. If you put it into Prolog, that will help you with the next part. Yeah. Yeah, there was one right before it. I give you the syntax for it right before that section of the lecture, right prior to it. The one in which you're going to be interested in looking at for the homework assignment is, I believe, number 4, but let me just verify that. Yes, number 4 is on Prolog. This is the last 1 through 4 are going to be due before you come here the next time on Thursday, November 8th, I believe. All the other stuff is due. The midterm and the CSLO is due on December 14th after the second class meeting. I stretched it out because these classes are so back-to-back right now. This assignment here is on the same premise, works with the same concept. So you can work towards this with the class exercise. This will help you actually complete this assignment. Because in this assignment, you're writing a Prolog program that implements a family database for your family. If you don't have a family, you don't know about your family, make it up. So save it as an ordinary text file, name it family.pro. Your program should implement the following facts for your immediate family, grandparents, and great-grandparents. You don't have to go back that far. But isn't this what you're doing in the exercise? You're doing the same thing in the exercise. But you're not doing the whole thing. You're just giving me the statements that are going to define the certain pieces. So that is, your database should consist of the number of facts about who is a parent of who, and about the individuals who are male, and about the individuals who are female. For example, parent of, then we have Joe Susie, Joe Don, male Don, male Joe, female Susie, female Mary. And then all the other predicates should be implemented as rules. And examples here, and if you're not familiar with what the predicates are, this might help you with the assignment actually. Here's some examples. Predicates involving variables and logical expressions with the colon and the minus sign. For example, hint, 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 hint. These are the answers that you're going to be writing for A through C of the exercise today. This is the rules that you're going to be giving for each one of them. So read through it, digest it to the point where you're understanding what I'm telling you here, and then you'll be able to do it with no problems. It's actually fairly easy. I'm giving you the answers here. So define the following predicates for the database. Your database should be rich enough to test for all the predicates. As an example, if there's only one child, then you have to make up fictitious siblings to test the sibling of predicate. So if you're an only child, don't worry about it. Just make the stuff up. It's your artificial family. How's that? In fact, you can make up your perfect family if you think you want a perfect family. Or if you don't have a perfect family and you want a perfect family, make it up. This is your artificial family. Some of the predicates may be defined in terms of the other predicates, obviously. For example, a sister is a female sibling and a grandparent is a parent of a parent. Ancestors of predicate can be defined recursively to handle ancestors of any generation, actually. So the assignment and the last exercise sort of work together. So now that we're sort of wrapping up the lecture part for this term, for this weekend, I thought I would take a look at the book to tell you which chapters you want to be able to read. So you want to go through, and they're by sections. So section number 1, the introduction and the intelligent agents, is a good place to start. You want to read those 2 chapters. If you don't have this, see me at the end when I stop this video and I can give you information about the textbook. This is the textbook that you're looking at. And you want to read the introduction, you want to read the intelligent agents section. You also want to read the problem solving section. However, don't be concerned with, be concerned with this chapter here, chapter 4, Beyond Classical Search, and solving searching problems. So problems by searching. Do not be concerned with chapters 5 or chapter 6. Skim it if you want, you don't have to read it. So 1, 2, 3, and 4 are good chapters. You also want to read chapter number 7, which is on logical agents and agent theory. Next time, during the next weekend, we're going to go over classic planning and acting in the real world, and knowledge representation. We went over a little bit of knowledge representation today, or this weekend, but we'll be hitting more of it next time. Don't have to go through learning. You don't have to go through uncertainty, probability, statistics, kind of a hybrid with statistical analysis. Really, up to this particular section is as far as we're going to get in this book. As I was mentioning on the first day, this is this is 1,152 pages. We're going to hit half of it. This is like a whole year course. This is like half. We're doing half this. So hopefully that will give you the information that you need if you're concerned with the reading. This is what you want to focus on. The final exam that you're taking next time is going to be more heavily focused on the beginning of the course versus the end of the course. It will not be a comprehensive exam that covers the entire course. This weekend's material, the reading I just gave you, is what's going to be on the exam. Nothing else. So you don't have to worry about what happens if I have to come here, then I have to go Friday, I have to go Saturday, and then I have to take an exam on Sunday. So this will hopefully narrow down, make it more manageable for you in terms of the content. Questions about what you need to do between now and next weekend that we meet. And the next weekend that we meet is actually coming up quite soon. It's November 9th, 10th weekend. So the 9th, 10th, and 11th is the next time we're meeting, which is about 2 or 3 weeks from now. 3 weeks maybe. 3 weeks from now. So in 3 weeks you have to do 4 assignments. That's it. And if you can get the reading done from the book, you'll be prepared, more than prepared for the final exam. And then when you come back, we'll have the final exam on Sunday. We'll have 2 days of more exercises, and you'll actually have an opportunity to work on the 4th and the 5th assignments. And I believe there's only 5 assignments. Let me just make sure. Actually, if I bring up the syllabus, I can tell you for sure. The rest of the work is not due on the same day as we meet. It's going to be due after we meet. So, looking forward to the next time that we visit here, we have at the end of the next meeting. So this is wrong. The midterm is not due on November 9th. Excuse me, November 8th. The midterm is not going to be due till December 14th. So at the end of this, we'll have the midterm and the CSLO and assignments number 4 and 5 that will be due at the very end, which is going to be, depending upon the timing, and I might extend the 14th. It depends on how we feel, because there's a lot of people in the Oracle class too. So we'll kind of touch and go, but plan on the 14th. I don't know how much longer I can extend that out without getting in trouble from the administration, but we'll see. Questions, comments, or concerns? No? First. It's a first. No questions. Well, as soon as I stop the video, I'll get tons of questions. So let me stop the video.